Let us look at another example of solving linear programming models using the graphical method. A company manufactures two kinds of microwave, premium and super. The profits are $40 and $30 per microwave respectively. Premium microwaves require twice as much time as required for super, and if all the microwaves were of super make, the company could make 1000 microwaves per day. The raw material for both the microwaves is common and is sufficient to produce 800 microwaves per day, both premium and super combined. The outer casings of the microwaves are procured from two different local suppliers. The suppliers of premium model can deliver 400 casings per day, while the supplier of super model can supply 700 casings per day. We are being asked to find out what quantity of each microwave should be produced to maximize the profit. So let us first understand this example in detail. So we have two kinds of microwave, premium and super. So let's suppose that this is premium and this is super. So these are the two types of microwaves. So we have been given that the profit for each piece of premium microwave is $40. So profit is equal to $40, and the profit for each piece of super microwave is $30. Next, we have been given that premium microwaves require twice as much time as required for the super microwaves. So if we assume that the time in minutes to manufacture super microwave is T, then the time to manufacture each piece of premium microwave becomes 2T. So let us note that down. So time in minutes per piece, this is equal to T, and time in minutes per piece for premium is equal to 2T. Now this example considers that the manufacturing facility has a limited capacity with which you can either manufacture only the super type of microwaves, or you can manufacture only the premium type of microwaves, or you can manufacture a partial quantity of super and a partial quantity of premium microwaves. So if all the microwaves which are being manufactured are of super make, then the company could make 1000 microwaves per day. Manufacturing capacity is equal to 1000 pieces. Now the raw material for both the microwaves is common and is sufficient to produce 800 microwaves per day, both premium and super combined. So we already saw that the manufacturing capacity in terms of time was to be able to manufacture 1000 pieces of super microwave. Now another constraint is the raw material. So the raw material which is available is sufficient to produce 800 microwaves per day, and this raw material is common, so this is good to manufacture premium and super combined. So raw material availability is equal to 800 pieces per day. The outer casings of the microwaves are procured from two different local suppliers. So the outer casing of these microwaves has to be procured from other suppliers, and there are two suppliers, one for premium model and the other for the super model. The suppliers of premium model can deliver 400 casings per day, while the supplier of super model can supply 700 casings per day. So even though we can produce 800 microwaves per day combined, for each of the types there is a limitation in terms of the availability of casings. So for premium model, the max production can be for 400 pieces, while that for the super model, the max production can be for 700 pieces. So 400 plus 700 is 1100, but the total raw material availability is 800 pieces per day. So what this means is that we can manufacture a combined number of 800 pieces per day as long as we don't manufacture more than 400 pieces for premium microwave and 700 pieces for the super microwave. So with this information, we are being asked to find out how much quantity of each microwave should be produced in order to maximize the profit. So we can produce a maximum of 400 pieces for premium and a maximum of 700 pieces for super, but there are various constraints given to us. So based on all these constraints and the other information provided, we now need to find how much should be manufactured for premium microwave and super microwave. So let us look at how to solve this using the linear programming models. Now the first step to solve this using linear programming models is to determine the decision variables. Here we are being asked to find the quantity of each microwave, that is premium and super. So let us consider X as the number of premium microwave to be manufactured. And Y as the number of super microwave to be manufactured. Here X and Y are the decision variables. The next step is to identify the objective function. The objective here is to maximize the profit. So let's say P is the profit and we need to maximize the profit. Now we have been given that each unit or each piece of the premium microwave gives a profit of $40. So one unit gives a profit of $40, and we already assumed X as the number of premium microwaves that we are going to manufacture. So X is how much? So let's say this is X1. So cross multiply, X1 multiplied by 1 is equal to X multiplied by 40, or X1 is equal to 40X. So the profit for X numbers of premium microwave will be 40X. So let's note this down. Now for the super microwave, each unit gives a profit of $30. So we have already considered Y as the quantity of super microwave to be produced. So for Y, let's say the profit is Y1. So cross multiplying, 1 multiplied by Y1 is equal to 30 multiplied by Y. Y1 is equal to 30Y. So the profit is 30Y. So this becomes our objective function. P is equal to 40X plus 30Y, and we want to maximize profit. Now the next step is to identify the constraints. So for the first constraint we have been given is that the premium microwave requires twice as much time as required by the super microwave. So let's say the time required for each piece of super microwave is T. So then the time required for each piece of premium microwave will be 2 times T. Now this time is in terms of each piece of super and premium microwave, and we have already considered X and Y as the number of premium and super microwaves to be manufactured. So let's find out how much is the total time required for premium and super microwaves to be manufactured. So for premium microwave, each piece requires 2T minutes of time. So this is in minutes. And we have considered a quantity of X. So X numbers will require 2T multiplied by X amount of minutes. Similarly, for the super model, each piece requires T minutes. So Y pieces will require T multiplied by Y minutes. Now, considering that we are going to manufacture a combination of premium and super type of microwaves, the total time required to manufacture X and Y number of premium and super microwave respectively would be 2Tx plus Ty. So this is the total time required to manufacture X numbers of premium microwave and Y numbers of super microwave. Now we have also been given that if we were to manufacture only the super microwave, then from a time constraint point of view, we can manufacture 1000 microwaves in a day. So basically here we have not been given the total number of minutes for which the manufacturing facility is working. It could be a 8-hour shift, it could be overtime for 10 hours, it could be a 16-hour, two shifts. So what we have been given is that in a day, maximum manufacturing for the supermodel can be for 1000 pieces. And we have already considered that T is the time required to manufacture each piece of the super microwave. So each piece is T minutes. The total time available in a day is equal to 1000 multiplied by T. So this is the constraint in terms of time, that the total time available in a day is 1000 multiplied by T. And if we are manufacturing a combination of super and premium, then we already arrived at this equation that the total time is 2tx plus ty. So this should be less than 1000 T. So our first constraint becomes 2tx plus ty is less than or equal to 1000 T. Now in this equation T is common, so we can divide each number by T. So we get 2x plus y is less than or equal to 1000. So this is our constraint number 1. Now the next constraint that has been given to us is that the raw material for both the microwaves is common and is sufficient to produce 800 microwaves per day, which is combined for premium and super microwaves. Now we already considered that X is the number of premium microwaves that we are going to manufacture and Y is the number of super microwaves that we are going to manufacture. And what this constraint is saying is that combined premium and super, you cannot manufacture more than 800 units. So what this means is that X plus Y has to be less than or equal to 800. So this becomes our second constraint. Next, we have been given that the suppliers of premium microwave can deliver only 400 casings per day. So basically you cannot manufacture more than 400 numbers of premium microwave in a day. So what that means is that X has to be less than or equal to 400. This is our third constraint. In case of super microwave, we have been given that the suppliers for super microwave can supply 700 casings per day at the maximum. So Y, which is the number of super microwaves to be manufactured, has to be less than or equal to 700. So this is our fourth constraint. So let us now see how we can solve this linear programming model using the graphical method. In order to plot the graph for these equations, let us assume that the horizontal axis, which is the x-axis, represents the quantity of the premium microwave, and the vertical axis, which is the y-axis, represents the quantity of the super microwaves. Now, since the non-negativity restriction on linear programming models is that x and y, or the decision variables, should be greater than or equal to 0, we are considering this graph to be the first quadrant where both x and y are either 0 or positive. So first we'll start with plotting the constraints so that we can eliminate the area or the values of x and y which do not meet these constraints. So in order to plot the constraints, we'll drop the inequality sign. So we'll consider 2x plus y is equal to 1000, x plus y is equal to 800, x is equal to 400, and y is equal to 700. All of these equations are linear equations, so these will form a straight line. In order to plot the first line, which is 2x plus y is equal to 1000, we need to find 2 points through which this line passes. Then it will become very easy to plot this line. Now the easiest points would be the y and the x intercept. So this line, when it intersects y-axis, the value of x will be 0, and when it intersects x-axis, the y value will be 0. So let us now find out the x and y intercepts for this equation. So the first equation is 2x plus y is equal to 1000. So in this, let's first put x is equal to 0. So that gives us y is equal to 1000. Similarly, if we put y equals to 0, we'll get 2x is equal to 1000, which gives x is equal to 500. So this line has an x-intercept of 500 and a y-intercept of 1000. The second equation is x plus y is equal to 800. So in this, if we put x is equal to 0, we get y is equal to 800. And if we put y equals to 0, we get x is equal to 800. The next constraint or the next equation is x is equal to 400. So this itself is easy to plot. The next one is y equals to 700. So again, this one also has enough information for us to plot on the graph. So now let us draw these lines with these information. So the first line, 2x plus y equals to 1000, has a y-intercept of 1000 and an x-intercept of 500. So let us plot this line. So this line represents 2x plus y is equal to 1000. Next, let's plot the line x plus y is equal to 800. This line intersects both the x and y axis at 800. So let us plot this line. This line represents x plus y is equal to 800. Next line to be plotted is x is equal to 400. So this line doesn't have a y-intercept, or the coefficient of y is 0. So it does not intersect the y-axis. What that means is that this line is a straight line parallel to the y-axis with an x-intercept of 400. So let us draw this line. This line represents x is equal to 400. So all the points on these lines represent the equation which has an equal sign. So suppose this line represents 2x plus y is equal to 1000. And all the points below this line represents 2x plus y is less than 1000. Similarly, this line represents, say, x plus y is equal to 800, and all the points below this represent x plus y is less than 800. Similarly, for this line, which is parallel to y-axis, all the points on the right hand side show x is greater than 400, and on the left hand side they show x is less than 400. Now the fourth line is y is equal to 700. Again, this doesn't have any x-intercept, so this line is going to be parallel to the x-axis and a y-intercept of 700. So let us draw this line. So this line represents y is equal to 700. All the points above this line represent y is greater than 700, and all the points below this line represent y is less than 700. So if we note down the direction where each of these lines exhibit the less than inequality, so this is on this side, this is again on this side, this is on left hand side, and this is downwards. Now the area common for all these four constraints is the feasible solution region. So if we consider the origin as O, this intersection here is A, this one here is B, this here is C, this is D, and this is E. So O, A, B, C, D, and E is the feasible solution region. So each point in this feasible solution region gives a value of x and y, which is a possible solution. However, we need to find the point or the value of x and y at which the profit can be maximized. Now there are two ways to do that. First is that we can draw a series of parallel lines for the objective function, which is p is equal to 40x plus 30y. As we move further from the origin, the line which touches the feasible solution region and is farthest from the origin will be the line at which the optimal solution will be available. Then we can find the coordinates of the point at which this line is touching the feasible solution region, and that will be the quantity of x and y that we want to manufacture. The second method is that we can find the coordinates of the edges, which is O, A, B, C, D, and E. Now this theory says that the optimal solution would lie on one of these edges. So if we find the coordinates of these edges and we solve the objective function equation, which is p is equal to 40x plus 30y, with the value of these coordinates for x and y, the coordinate which gives us the maximum profit would be the coordinate at which the optimal solution lies, and the value of x and y at that coordinate will be the quantity of premium and super microwave that needs to be manufactured. So let us do the second method, that is, we'll find the coordinates of A, B, C, D, E, and O, and we'll use them to find out the coordinate which gives us the maximum profit. So in this graph, the coordinates of O are 0, 0. For A, since this is intercepting the y-axis at 700 and the x-axis is 0, the coordinates become 0, 700. For B, the point B lies on the intersection of this green and the gray line. So if we solve these two lines as simultaneous equations, the value of x and y will give us the coordinates of the point B. Similarly, point C lies on this green and the red line. So if we solve these two equations, we'll get the value of x and y coordinates for the point C. For point D, again, it lies on the intersection of this red and pink line. So if we solve these two simultaneous equations, we'll get the coordinates of the point D. For point E, the value of x is 400 and the value of y is 0. So the coordinates become 400 and 0. So now let's solve the equations to find out the coordinates of B, C and D, and then we can use the coordinates of A, B, C, D, E and O to find out the coordinate which gives the maximum profit. So as we saw earlier, the coordinates of point A are 0 and 700. For B, we need to solve the equations y is equal to 700 and x plus y is equal to 800. So if we put y is equal to 700 in this equation, we get x plus 700 is equal to 800. We take 700 on the other side, so x is equal to 800 minus 700, or x is equal to 100. So for B, the coordinates are 100 and 700. 700 because it's already given that y is equal to 700, so we don't need to solve anything to find the y coordinate. For C, we need to solve the equations 2x plus y is equal to 1000 and x plus y is equal to 800. So 2x plus y is equal to 1000 and x plus y is equal to 800. So let's subtract the second equation from the first equation. So y minus y gets cancelled. 2x minus x is equal to 1000 minus 800 is 200. So x is 200. Now if we put x is 200 in this equation, we get 200 plus y is equal to 800. Y is equal to 800 minus 200, which is 600. So for C, the coordinates become 200 and 600. For D, we need to solve x is equal to 400 and 2x plus y is equal to 1000. Now I hope you're clear as to why I'm saying we need to solve these two equations, because point D lies at the intersection of these two equations, or these two lines represented by these two equations. So if we put x as 400 in this equation, we get 2 multiplied by 400 plus y is equal to 1000, or 800 plus y is equal to 1000, or y is equal to 1000 minus 800, which is 200. So the coordinates of point D is 400 and 200. And we already know coordinates of point E are 400 and 0, and the coordinates of point O are 0, 0. So we now have the coordinates of points A, B, C, D, E and O. Now let us put these coordinates, or the values of x and y, in the objective function to solve for P and the coordinates which give the maximum value of P is the point which is the optimal solution. So our objective function is P is equal to 40x plus 30y. So if we put the coordinates of A, which is 0 and 700, we get P is equal to 40 multiplied by 0 plus 30 multiplied by 700. 40 multiplied by 0 is 0. 7 multiplied by 3 is 21, and then we'll bring down all the zeros. So 0, 0, 0. So profit, if we have the value of x as 0 and y as 700, is $21,000. So let's say this is 1. Now for B, the coordinates are 100 and 700. So if we put the value of x and y in the objective function, the value of P becomes 40 multiplied by 100 plus 30 multiplied by 700. So 40 multiplied by 100 becomes 4,000 plus 7 threes are 21 and 3 zeros. So this becomes 21,000 plus 4,000, which is 25,000. So let us say this is 2. Next, let us take the coordinates of point C. So the coordinates of point C are 200 and 600. Let us put these values in the objective function. So we get 40 multiplied by 200 plus 30 multiplied by 600. So we get 4 multiplied by 2 is 8 and 3 zeros. So 8,000 plus 3 multiplied by 6 is 18 and 3 zeros. So 18,000 plus 8,000, this is 26,000. Let's say this is 3. Now let us take the coordinates of the point D, which is 400 and 200. So the value of P becomes 40 multiplied by 400 plus 30 multiplied by 200. This is equal to 16 and 3 zeros plus 3 multiplied by 2, 6 and 3 zeros. This is equal to 16 plus 6 is 22,000. Let's say this is 4. Next, let us take the coordinates of point E, which is 400 and 0. So our objective function becomes 400 multiplied by 40 plus 30 multiplied by 0. This is equal to 4 multiplied by 4 is 16 and 3 zeros plus 0. So this is 16,000. Let's say this is 5. Next, let us take the coordinates of point O, which is 0 and 0. So P becomes 40 multiplied by 0 plus 30 multiplied by 0. So both are 0, so this is 0. This is 6. So now we have the value of P for each of the coordinates. Let us now evaluate which coordinate gives us the maximum value of P. So A gives 21,000, B is $25,000, C is $26,000, D is $22,000, E is 16,000, and O is 0. So the value at the coordinates 200 and 600 is the maximum. So C is the point where we get the maximum profit. What this indicates is this is the value of X and this is the value of Y, and we had assumed that X is the quantity to be produced for the premium microwaves and Y is the quantity to be produced for the super microwave. So premium quantity is 200 numbers, and for super the quantity is 600 numbers.